Hello everyone, welcome back to my channel. Today, let's go over a medium level question that I just solved on my own. So I'm super happy about this, and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3759, count elements with at least k greater values. So you're given this integer array nums, and you're given an integer k, and you want to count how many elements, how many total elements in nums basically have a condition where there are at least this many elements inside of the total array that are strictly greater than that element that we're looping through. So for example, if this, we're looking at 2, how many are bigger? 1. So exactly 1, so that counts. And 1 has 2 bigger, so that's bigger than or equal to at least k. So that's going to be 2 in total elements that satisfy this criteria. In this case, 3 doesn't have any element that's bigger than it. So pretty straightforward. Let's go ahead and sort the array first, right? So we sort it, and then let's go ahead and run a binary search, because what we're going to do is when this is sorted, we're going to run a bisect right, and we're going to find the point at which basically this gives an index where it's the very next element that's bigger than the current element we're iterating over. So if we're on 2, then this bisect right is going to give us an index 3 if that is a valid index inside of the array, right? So that's how bisect right works. So let's go ahead and do that. And so let's do that. So for I and enumerate nums, let's call this BL. And also let's actually make a dictionary to store the values that have already been used, because this may have duplicates, right? And as that array gets very large, that may cause issues. So if n is already in D, and if dn, let's just label this as good, then we can just add to an integer answer 1, right? Because this is already used. So it's already a good one, and we can just continue it. Otherwise, if it's not processed, then we can run a bisect right to find the point at which is greater than right. The soonest point that's greater than the current element inside of nums, which is already sorted, which is why this binary search works. And we're trying to find that for n, the first point that's bigger than n. And then let's take the difference, which is just going to be the size, because let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and then we're on 4. Then bisect right is going to give us 5. And then if we take the total number of elements minus whatever we bisected, that's going to be the leftover elements that are strictly greater than 4, right? So then we can just say BL, or the size minus BL. And then we can go ahead and say if diff is bigger than or equal to k, because that has to be at least greater than or equal to this number k we're given, then we can go ahead and say it's good, right? And then while we're at it, let's go ahead and process it. Let's put n into the array and call it good, so we don't have to pre-process this log of n operation every time. Okay, so at the end we can just return answer after we counted all the values that qualify. And let's run this, submit it, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.